Hey guys, Great Gamer 34 here. Today, another resume on this tutorial. I'm sorry, I've been busy lately with school. I shouldn't say much with school, but senior year and doing stuff. I'm making videos on other stuff, and tutorials are really boring to make for me. But I know you guys like them, so I'll try to keep them coming. Today, we're gonna work on our CPU some more, and we're actually gonna start with the program ROM. So, start figuring out what we're gonna do. I need to get a wand. And let's stack, since we have to stack at 62 approximately, that's what I would say. No. Oh, I only have a 4-bit address. Okay. Undo, we're gonna have to stack at 31. Okay. And actually, why don't I do it like this? Bam, bam. Stack 14. There we go. Might have to make some minor changes to this, but that's alright. So we're gonna click up there. Down here, and I'm pretty sure this is like 20 bits that I have to stack, so stack 20. So I'm just loading. Oh man, I just dropped some redstone dust. Okay, so now let's color code. So let's look at the instruction set. So the opcodes are blue, so our opcodes are blue over here. So let's get some light blue wool, and we're gonna go right here, 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 and here, and overlay that with redstone. Our right on this our right is green and the other two are not, so I really don't feel like finding a link. So our right is going to be lime green. That's all the way over here if you built this the same as me. And I always color code it the same as my instruction set so I don't get confused. This top one is read A, so read A over here is orange. And then I'm pretty sure the next one is yellow. Yep. And then the immediates are red. And now we have our color code. Now what we're going to have to do is wherever there's a torch on this decoder, we're going to have to flip it to the other side. So that's every other one. Except for when we have to move 2. Which is only every other time. And you'll see why. We're going to have to move 2, and then next time it's going to be 3 that we're going to have to move. Looks like we're missing something. We're missing a repeater in this decoder. I think I came back and double checked. Okay, and then just add some repeaters here. Like so. Stack or copy from that location and that location. Add some signal strength repeaters. I guess that's all repeaters should do. Oh, that could go one more. But we'll keep it like that actually. And stack 14. Then we have to find the farthest distance away, which would be on this side, because it's the side that we place torches, so. And it has to be underneath. And that reaches. But just in case, I'm just gonna do this. Position 1. Position 2. Stack 20. And that should reach all the way to here. Yep. So now our ROM is done. Let's hook up our program counter. So let me just do an unconditional, or a direct jump to line 0. This should be, as long as there's no inputs, but there is. Or oh, that's counting outputs, right? Jump to line 0 and hook her up. Just gonna position this up a little higher. Do a little spiral with this one, like so. Now you guys can have more program ROM by making the decoder larger and using larger CLE. Or you can just use a T-flip-flop based program counter, which I've done plenty of times. Now let's conditionally jump to line 15. So it's enabled to go through. Give it the location of 15. And make sure that lever's up and press it, and it'll go in. And then we'll add our repeaters that will reach. So repeater's going to go here, 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 and here. And it's turning off. So that's good. So now let's get rid of our inputs by not allowing them to go through. We'll clock it and put it at line 0, which we don't actually have a physical address for line 0, and then now we're going to do some more instruction decoding now that this is hooked up. Alright, so now what we're going to do is we're going to start building our RAM, and this is the type of RAM that we're going to use. It's single read, and that's all we really need. And if you notice, it's repeater lock memory, and it's really compact, and it outputs on the same line that it inputs on. So if we're going to go ahead and start up here, and I'd like to give credit to Nathan, or Entweed, it goes by in the game. Oh, Jalen's referring to me right now, but I'm in the middle of recording it. So we only need 4 long, and it's actually going to alternate back and forth like this. And And then this is going to power into a repeater, like so. Like that. Next thing we need is a repeater like this. And then we're going to connect it like so. And it's going to power into another block like this, and then down and under. Voila. Okay, so now what we're going to do is we're going to bring it down like this. We're going to put a torch for that. It's actually going to be up. Oops. It's actually going to be done like this. And then over here we're going to put our reed. So we're going to put our reed like this. Now, yes. So now we're going to have to come down here. And we're just gonna, this is gonna be our bus. So then we gotta bring this up. And we gotta use the half slab right here. So that can still go over it, like so. We're gonna then just bus right here. And so if you notice, this design tile's too wide. So this is 2 bits. So basically, here's your input. The right is inverted, and the read's inverted. Like that. So there's read. We put a button here for right. Don't know why I grabbed a wooden one. And then here's the data. So we input a 1. I write it to that cell. Right to this cell. What? And then I try to read. It'll read a 1. If I want to write a 0 back to both of those cells, I just do that. Try to read, I'll get a 0. I put data in there. Write to it. Stop giving data. I get a 1 out, and then if I flip data down on both of them, right, and then that I'm reading. So that's basically how the cell works. So now we're going to come to the back of our CPU so far, and since the data isn't inverted going in, we have to actually re-invert it. But what we're going to do is we're going to find the median. It's approximately this one. There's 4 on each side, so I guess these 2 are the middle, so we'll just have this one meet up and this one come down, and here's the middle. So this one just needs to come up. I should take it from here. I'm not sure how far the signal is going to reach. What we'll do with that as we get through that issue. Just gonna do it like this for all of them. just gotta bust these down. Yeah, let's just see how far our signal will reach. I do this. Oh wait. There. There. Somebody's working on programming a bot for the IRC. IRC happens to be Internet Relay Chat, and it's a way of communicating with the server, and just a way of communicating with other people. And there's our busing. So actually, let's take the cell that we built. Position 1, not position 21 or 12. And position 2. And let's copy it from here. What we're going to do is paste it here. That. Moved before it pasted. Paste -A, and then one more time. So now we have a byte of RAM. We have 1 byte of RAM, and that's all it takes up. Now what we actually have to do is find some sort of way to bus the outputs of here to the inputs of here. Okay. So I'm gonna just come from the... Oh, also, important, we're using the top input here because this is the B input into the CPU. Four more. Let's see. We can move this one down. Like so. Let's actually undo all that, and let's get this bust to approximately just laying out some wires right now for testing. 2 more bits. Let's start placing redstone. Don't worry about things overlapping right now, we'll fix that later. If you use the single read registers, the two sets of single read, you can just bus the RAM, or build your own RAM, or how you could even use the same type of registers that you used. If you used single read registers, you can actually use those registers as RAM also, and just bus it back through the inputs. I'll show you an example of that on another CPU I've made. Let's come up with this. Oh, that doesn't solve the issue very well, does it? This does. There we go. I don't know why I did all that though. 1, 2, 3, 4, 5, 6, 7, 8. We have 2 more to bus. Oh, that is right. I did it so we can get a line underneath. One more. So let's see what happens if I paste -a here. Let's see, right here, paste -a. Yeah, we get around that though. That works. We'll paste it here also, and then we'll also paste it here. So there's our 1 byte. Now, yes, because we have data being read in or something like that. What the heck? Oh, block update. Okay. There we go. So we have the same signal strength now. And let's hook up our reads. I just broke some other line, but oh well. Why is this blinking? Uh-oh. Let's go ahead and invert the read, or power the read so it's not actually reading anything. You notice we get a little short. It's actually going to be done like this. These all have to be connected. And we've got to continue hooking up our reads. Or our outputs, I should say. Okay. So now, what we have to do, we have to paste here. I have to repaste. How it will be done. So there. And we'll stack it after this because we want 16 locations, and we have right now it reminds me, we also have to block off like so. Right now we have 2 locations for RAM. We want 16, so I'm going to actually stack this 14 times with my selection being 1 minus what we have already. If that makes sense. So I'm going to go connect all these right after I get done. Right after I do this. This is only temporary, but I'm going to come down here. Position 1. Position 2. We're going to stack 14 times if you do the same exact thing as me. And now we have RAM. So the next couple of CPU tutorials, I just gotta load all the RAM that I need. So the next couple CPU tutorials will be configuring the RAM to work properly, jumping, branching, and the rest of it are instruction decoding. So thanks. If you guys want to take the initiative, make sure repeaters reach and all that stuff, but I'm going to cover that in the next tutorial. So thanks, subscribe, and see you guys next time.